Okay, today you're going to be graphing polynomials using the graphing calculator. So this time you can use Desmos so we can find the absolute max and absolute mins, relative max, relative mins. Without the calculator, you could not do that. You can only sketch. So start these problems out just with sketching because sketching is harder than just plugging into the calculator and looking. So leading coefficient is 1. The number in front of your highest degree exponent. So my degree is 4. So my leading coefficient is positive. That means the right side goes up. My degree is even, so my left side does the same thing. So it is also going to go up. Some of these won't be factorable, but it looks like this one is. So if you can factor it, that is great. It'll help you make sure you plug into the calculator the correct way. Greatest common factor is x squared, and then I'll be left with x squared minus 16x plus 64. Okay, so that's x squared. What multiplies to 64 and adds to 16 is negative 8, negative 8. So x equals 0 from this 0, and x minus 8 equals 0. Set both of your factors equal to 0 and solve. Obviously, that one's already solved, but this one's positive 8. There's 2 of those, so that's a multiplicity of 2. 0 also has a multiplicity of 2. A good way to check that you got your multiplicities correct is it should add up to give you your degree on all of these. So even if we go backwards, 3 plus 1 adds up to give me my degree of 4. Keep going backwards. 1, 2, 1, degree of 4. 1, 1, 1, degree of 3. So to check any of the multiplicities, you can see if they add up to give you your degree. That will check your degrees right and if your multiplicities are right. Evens, bounce. That's from yesterday's video. If you missed it, go back and watch it. I don't expect you to know how to do this unless you watch the video or go to tutoring. If you went to tutoring after school yesterday too. Your y-intercept is when your x equals 0. So you're going to plug 0 into your equation. 0, 0, 0, 0. So here's 0, 0, and 8. 8, 0. I know I'm going to bounce off of this one and bounce off of that one. So this is going to be in pencil. We're going to have to erase it because we're going to find the max and mins. But we know it should look something like bounce, bounce, and up. That's ugly. We're going to get it more correct because we're actually using the graphing calculator. But they end up and they both bounce off of this one. So I go over to Desmos and graph it. X to the 4th minus 16x cubed plus 64x squared. I see my zeros. I do see that they bounce, so that's good news. Now let's find that maximum. Relative max and relative mins have to be graphed. Okay, there it is. Now let's zoom in here and here. 50 and 50, who knows? So I'm going to guess negative 10. That'd be 100, that'd be 50, positive 10, positive 20. Positive 10 is my graph. There we go. You can see it now. Here's my relative maximum, relative minimum, absolute minimum. Those are my minimums. Absolutely nothing's below it. So on my graph, I have to go to 256. That's a really big number, so I'm probably going to count by 25s. 25s would only get me to 250, so 30s? We'll count by 30s. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. There we go. And so it was 256, 256, right in between there. It goes up, bounces off of my 0, just like a quadratic would, because it has a multiplicity of 2. Touches, does not cross. You shouldn't be over here in the x's at all. Comes back up. I'm counting this side by 1, so at least mark a few of them. And you're just copying that graph. So basically what we did yesterday here, except now we can actually find out this absolute maximum is for 256. Okay, So relative max, there's just one relative max, and that's your absolute max. No, sorry. I'm thinking relative min, sorry. Your relative max is that 4,256. There's no absolute max because the graph goes up forever, so there's still more numbers up there. Relative min and absolute min are the same because there is an absolute min. There are no points lower than that. So it'd be 0, 0 or 8, 0. Minimum is the y values. So that's how you know if it's a minimum or not. Domain of these polynomials are still the same, negative infinity to positive infinity, left forever, right forever. But now the range, we don't have to have a question mark because I know my absolute minimum is 0 to infinity. Okay, let's do one more. This one also graphs nicely, but if it didn't and you had to find your zeros anyway, you would just use Desmos to figure out what those zeros are. So x is my greatest common factor, so I'm going to factor that out. You can already know your leading coefficient is 1. Your degree is 3. Leading coefficient of 1 is positive, so the right side of my graph goes up. And then the degree is odd, so my left side does the opposite. It will go down. Okay, and then back to factoring. X is my greatest common factor, so I get x squared plus 6x plus 8. I think this was one of the ones on your worksheet yesterday, to tell you the truth. So what multiplies to 8 adds to 6 I already did was 2 and 4. So there are 3 zeros here and not enough spaces, so we're going to just divide one of these in half because we have x equals 0, x plus 2, so equals 0, so negative 2 and negative 4. Multiplicities are 1 all the way across, so that will be cross, cross, cross. Remember, multiplicities of odds cross or cross flatten. Odds over 1, 3, 5, cross flatten. And then even multiplicities bounce. So if these are crossing at 0, negative 2, and negative 4, we're just going to cross through it, cross through it, cross through it. Looks like an N, I think. We already know my y-intercept is 0, 0 because it's right here. Or you can plug 0 into your equation and get that, and then we'll graph this equation. Don't graph your factors in case you factored it wrong. Okay, when I graph it, I can find my absolute max, absolute mins, but it looks like 3, negative 3.2, 3.1, negative 3.2, 3.1. And it crossed through here, and then it crossed through here. Then my relative minimum, negative 0.8, negative 3.1, negative 0.8, negative 3.1. Crosses through there and goes up. You know you did it right because your end behaviors are right, and because you can just look at the graph. Makes it a lot easier. Domain, all real numbers. Ranges, all real numbers as well. Negative infinity to positive infinity, down forever, up forever. Last part is identifying things we know and writing the equation. So we're identify these and write an equation for these. That makes it a lot harder. So you know your degree is even because they're doing the same thing. They're both going down, your end behaviors. How many zeros you have? You have 1, 2 zeros. What are they? Negative 2 and positive 2. My y-intercept's up here at 0, 1, 2, 3, 4. So 0, 4. And then both my left side and my right side are going down. Left side's going down to infinity, right side's going down to infinity. So that's all the information I need to know to write a possible equation for this graph. So I'd have my zeros, and we're going to do the opposite of what they were. So my zeros was -2 and +2. It crossed directly through it, so we now have a multiplicity of 1 on both of these. That's really hard to read. Let me try to erase that. Meaning the exponent's going to be 1. And you set that equal to 0, so I'm going to add over 2. So x plus 2, x minus 2, and it has a multiplicity of 1. We do not know if there's a coefficient or what it is, but this is an equation. So we can figure out what the coefficient is. These are being multiplied by using a point we know. So one point we know is the y-intercept, 0. So we're going to use that point. Doesn't have to be the y-intercept, but it can't be the x-intercepts because that won't help us find a, because this would be 0 and that would get rid of our a. So we're going to plug 0 in for x and 4 in for y. So 4 is y. We're solving for a. I'm plugging 0 in for x and solving for a. So parentheses first. So it'd just be 2 times -2, which is -4. We've done this before, but I'm switching back and forth with quadratics. So a is -1. So the quadratic equation for this would be -1, x plus 2, x minus 2. And unless it says put it in standard form, that's fine. You can check your answer by graphing it. -1, oops, -1, x plus 2, x minus 2. Yep. So y-intercept of 4 goes down and hits both of those points. So you know you do it right. All right, pause this video and try to do the second one. See where you get stuck. You got to try before me. I'm going to count these all by ones, all of them, both of them, if you want to go ahead and do the second one too. Okay, hopefully you did yours or you went until you got stuck. Because you got to try ahead of me, or otherwise it's, I don't know what she's doing. I just copied it down. That doesn't help you. So if you try it on your own, you figure out where you don't know. Again, this degree is even because their end behaviors are doing the same. They're both going up. Numbers of zeros are 1, 2, 3, 4 zeros. And what they are, -2, -1, 1, and 2. -2, -1, 1, and 2. Y-intercept, 0, 4. We're across my y-axis. And they're both going up. So right side and left side are both going up. Right side and left side are both going up. Writing the equation, you're crossing through each one of these, so the multiplicities are all 1. So x minus 2 equal to 0. Well, x equals -2. I said that wrong. Is one of my zeros. So when you set that equal to 0, you add over 2. So all of these are changing signs. So if it equaled -1, that means in parentheses it was a +1. If it equaled +1, then in parentheses it's a -1. So I have to subtract the 1 over. If it equaled 2, then in parentheses it's x minus 2. And again, we have to solve for a, so we're going to use that extra point, which again happens to be 0, 4. And we'll plug it in. So 4 equals y is my 4, x is my 0. We're solving for a. So 0 plus 2, 0 plus 1, 0 minus 1. Some of you will skip this step. That's okay. I don't want to. I'm not there today. So 0 plus 2 is 2. 0 plus 4 is 4. -1 and -2. Multiply all those together. 2 times 4 is 8. -1 times -2 is +2. So 4 equals 16a. Almost there. Divide over by 16. So 4 over 16 is 1 over 4a. So then we can plug that into our equation. X plus 2, x plus 1, x minus 1, x minus 2. So there's our equation. And again, you can check it if you plug it in. So 1/4. 2 1, x minus 1, x minus 2. Plus 2 plus 1 minus 1 minus 2. There we go. Looks correct to me. So, no, it doesn't, because that should be a 4. Hold on, let me see what I did wrong. It doesn't look right to me because somehow 0 plus 1 became 4. And that's not right. So this is 1, so that'll change, and that'll change, and that'll change, and that'll change. So I'll change my color so you see what I messed up on. 0 plus, that looks like a 4. It was sloppy. It's a 1. So 2 times 1 is 2. Negative 1 times negative 2 is 2. So this would be 4. And 4 divided by 4 would be 1. So I think my coefficient is just 1, not a fraction. But let's check it and find out. There we go. Now it's reaching up to 4. That makes more sense. Okay. Again, pause the video. Try the next one. See where you get stuck. It's changing because now it's an odd degree. You pause and then come back. Seeing where you get stuck is seeing where you need to listen to me. You don't need to listen to me through this whole thing. You know these ends are doing opposites, so it's odd. You know how many zeros there are. There's 3. What are those zeros? Negative 4, negative 2, and positive 3. Y-intercept 0, negative 6. Now this one, it does matter which one is right and left. X goes to positive infinity, that's the right side. X goes to negative infinity, that's the left side. So the right side's the one going up, the left side's the one going down. They're doing opposites, odds, opposites. And then we're going to write our equation. We don't know what A is, we don't know what our leading coefficient is, but we know X plus 4, X plus 2, and X plus minus 3. Because we're setting these equal to 0. If, I don't like these examples because none of them bounce off. If one had bounced, then you could do an even multiplicity of 2. We'll have an example like that on our worksheet and on our review. So I do want to add, sometimes we will have multiplicities here, and that might change how we solve the equation. My extra point I'm using is 0. It's not 4 now, it's negative 6. So here's my X, here's my Y. 0 is the easiest one to do because then all of that becomes just whatever. 0 plus 4, 4. 0 plus 2, and 0 minus 3. Way easier. So negative 6. I don't know why it keeps jumping like that. There we go. 8. 4 times 2 is 8. Minus 3 is negative 24. Negative 24a. Divide by negative 24. So a is 1 over 4. That's where I got the 1 over 4 from here. A little ahead of myself. 1 over 4, and then go back and put these all in there. X plus 4 to the first power, you don't have to write it. X plus 2 to the first power, you don't have to write it. X minus 3. There are your equations. And again, this was just 1, not a fraction. Okay, you have a worksheet to complete. Please complete it. We'll be turning it in tomorrow as homework. Good luck.